Okay, so today we're talking about experiments, not just observational studies, but there's actually a treatment that's happening with the experiment. Okay, if you did last night's homework, those are the answers to those questions. Okay, confounding. So response variable, we already know this. This is a review, measures an outcome of a study. Explanatory variable is the x-axis. We choose that, and we think it might explain or predict the outcome in a response variable. Remember, a response variable is usually something that's measured, which is the y-axis there. Confounding occurs when the two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. I really want you to copy down that definition. It's a good definition of what confounding is. It's how I think of it, and it helps you. There will be questions about confounding. It will help you to know the formula as you're describing what a confounding variable is. If you know the definition, it helps you to define that. You're supposed to, when you're talking about confounding, talk about how is associated and with the explanatory variable, the x-axis, and how it's associated with the response variable, the y-axis, right, in words, in context. So in a study involving more than 4,700 children, researchers from Cincinnati's Children's Hospital Medical Center found that those children whose mothers smoked during pregnancy were more than twice as likely to develop ADHD as children whose mothers had not smoked. Ooh, so might be better to not smoke. So is this explain why confounding makes it unreasonable to conclude that the mother smoking during pregnancy caused an increase in the risk? So it sounds, boy, when you first read that, don't you want to say, oh man, it sounds like the smoking caused the ADHD. It might have. We don't know. And that's the key. We just don't know. We would have to do an experiment to prove that. And so just knowing that, maybe there are some other, if you're smoking, you might be making other poor life health decisions here. That's not a good health decision to smoke. Maybe you're eating poorly. Maybe you're drinking or doing drugs. You might be doing some other things that are not very healthy for you if you're making a decision like smoking, which is not a healthy decision. We know that can lead to lung cancer. There have been experiments about that. So they said it's possible that women who smoked during pregnancy had less healthy diets, and so forth. And so smoking might have had no effect. We don't know, right? So on ADHD. So it's not that we're saying it doesn't, but we can't prove causation just by knowing there, because there could be a confounding variable. And if the study wasn't well designed, if it's not an experiment, you can't prove causation. A treatment is a specific condition applied to the individuals in an experiment. If an experiment has several explanatory variables, a treatment is a combination of specific values of these variables. Experimental unit is the object. Okay, so a treatment is, what you're getting with that. So it might be just as simple as giving out a drug to lower your cholesterol or something. It could be a drug. It could be some other variation of different levels of a drug, right? So an experimental unit is the object which you are treating, usually people, but sometimes things and sometimes animals. We will call animals, whatever we're doing the thing on, is experimental units, typically. A placebo is what the treatment group that gets no active ingredient. So typically, if I were testing a drug, I would randomly assign half of the people in the study to get the real drug and randomly assign the other half to get the fake drug, which is called the placebo. In an experiment, a factor is an explanatory variable that is manipulated and may cause a change in the response variable. And there are different levels of values of factor called levels. Okay, so I like this example. Have you ever dropped a piece of food on the ground and then quickly picked it up and I'm going to eat it anyway? We call it the 5-second rule. His rule is based on a belief that may or might not be true that says bacteria needs time to transfer. If you get it within a few seconds, it's probably fine. They put the 5-second rule to the test. So they dropped different pieces of food into 4 different surfaces: steel, tile, wood, and carpet. Carpet would be the worst of those, I think. And waited for 4 different lengths of time: 1 second, 5 seconds, 30 seconds, and 300 seconds. So I like this study. I like the way it's designed. So finally used to protect bacteria prepared 2 different ways: in a trophic soy broth or a peptone buffer, whatever those are. Once the bacteria is ready, the researchers spread them out on different surfaces and started dropping the pieces of food. After waiting the designated amount of time, the food was removed, blended, and plated into one of those different materials and tested. So what are the experimental units? Who are the people or things that are being tested here? I'm thinking it's pieces of food. So are there pieces of food that are being dropped, right? List the factors. So this one, and the number of levels for each factor. The way they asked the question, they said plural. Maybe there's more than one factor. So that might be kind of unusual if you're not used to this kind of question. And there certainly seems to be more than one level. So one factor, it looks like is the floor, different floor surfaces. How many different floor surfaces? Those are the levels. There are 4 levels of floor surface factor. So that's steel, tile, wood, and carpet. So there's 4 different ones of those. Another factor might be a length of time. And there were 4 factors of those, 4 levels of those, I should say. 1 second, 5 seconds, 30 seconds, and 300 seconds. So there's 2 different factors there, 4 levels each. And there's one more there. So the way they prepared it, I don't know how you want to say that, is the other factor. The levels of those are the soy broth and the peptone buffer. So you have 4 different types of surfaces, 4 different types of time, and 2 different types of preparation liquid or whatever that is there. So that's what they said. 4 levels of the type of surface, 4 levels of the amount of time, and 2 for the method of bacterial preparation. That was the wording I was looking for. If they did every possible combination of levels for this treatment, this reminds me of an Algebra 2 problem. How many different ways can you do this? You have to choose a level of the surface. What are the 4 ones there? Choose time, and then choose your preparation, bacterial preparation. So it would be 4 times 4 times 2, whatever that is, should be your answer. 32 different treatments. List 2, they just want to make sure you understand. So you could say, you could really choose any of them. So if you want to choose 2 of them, so you could say, okay, let's choose stainless steel, 1 second soy broth. That's one. Stainless steel, 1 second peptone buffer. That's a different one. They don't all have to be different just as long as one of them is different. They chose those 2, but there's no magic to that. You could choose whatever you want. That's the end of the lesson. Let's do a couple questions. A study of 14,702 people across 15 countries. Researchers found that people who visited a coastal area more often tended to have better overall health. In particular, those who never visited the coast were 2.13 times as likely to report they had bad health compared to those who visit the coast at least once a week. So we should all visit the coast. Explaining why compounding makes it unreasonable to conclude that taking frequent trips to the coast causes better health. So what could be some compounding variables there? I think of richer people going to the coast every week. So income could have an impact. Maybe healthiness of the food. So maybe when you go to the coast, you eat healthier. Maybe you eat more fish or something. That could be a compounding variable. Let's see what they said. Visit the coast, live close to the coast. Oh, so if you visit the coast a lot, maybe you're living close to the coast, which again could be that you are richer. You live very close to the coast. Both these are true, so you relation to visiting the coast frequently and better health. So again, like eating, etc., lots of those things. Lobster populations in some parts of the world are going down. One solution is to raise lobsters in hatcheries and then release them into the wild. Growing lobsters as large as possible gives them the best chance of survival when released into the wild. One experiment to determine the best nutrient levels used diets containing 2 different amounts of protein, 2 levels, 3 different liquid to carbohydrate ratios, 3 levels of that. And over a 32-day period, these diets were tested against a conventional diet of Antarctic krill was fed to some of the lobsters. Among the other variables, researchers measured the growth rates based on the length of the carapace, the upper shell section. What are the experimental units? I would think the lobsters. List the factors. So there's some for sure here. So different amounts of protein. So there are 2 levels of that, 400 and 500. Different. So another factor is the liquid to carbohydrate ratio, and the 3 levels of that are low, medium, high. I wonder if the krill is a factor or not. So no, so just amount of protein and the liquid to carbohydrate ratio. There's 2 levels of the first and 3 levels of the second. How many treatments were included in this experiment? So you had 2 times 3, so 6, right? So you multiply all the levels together, the number of each. The 7th, oh, so that's where that comes in. So right, there's 6 different combinations of those guys. The 7th treat was just straight up conventional diet of krill. So there are 7 different ones. So the 6 with the levels, and then they talked about an extra one. They were tested against, so they were compared to kind of a control group of the traditional way of doing it, which is krill. List 2 of the treatments. So again, you could just choose like 400, low level. That's it. They chose 400 and low. Oh, they chose that one. You choose a different one. There you go. That's the lesson for today.